Now I do it.
Now you do it. Hey, everyone. I am David, founder of Stately, and this is Gavin. Sorry, pointing the wrong way. I can't get used to the whole mirrored screen type of thing. So we're just doing a really impromptu stream today, and we are going to be talking about serverless workflows. And so this is something that we've been thinking about for a long time, where XState is useful in the front end, of course, like that's where a lot of people use it. But we've been seeing more and more people actually use XState and state machines in general in the back end. And so I think it's just a really good application for state machines because when you're describing a backend process, you're going from like step A, B, C, and you're sort of doing things sequentially, or something happens, you might branch off and do something else.
Right.
Yeah.
A lot of conditionals, a lot of, you can think of a really good example that I like to use is DocuSign, for instance, where you have these complex rules set up where one person can't sign a document before another person can sign a document. Maybe they're higher up or something like that. Those are typically rules defined on the back end, and they're just a natural fit for state machines in general.
Yeah, exactly. So I guess you come from a different background, like C# land or .NET land. How do you so how do you usually model things like sagas or workflows, or like what would be the typical thing that you would reach for and that most people would reach for in .NET?
Oh goodness. Well, in my experience, it's what I would consider pretty common parlance, right? So we historically it didn't look at things as state machines as so much as we did processes on the back end. So we would have we make use of heavily of the service repository pattern, where you have all of your atomic super incremental database reads and writes all in one place, and you have your actual services where you just string together all of that logic in another place. And that's a big pattern that we use. We also make use of the Saga pattern. A lot of event-driven architecture lives in ASP.NET and .NET, standard implementations. So that's pretty much it. But in terms of modeling your sequence diagrams, your component level architecture, or my favorite, a good old bulleted list of events that are supposed to happen, this, then this, then this, and then a little indentation, then this, and then come back out. That's typically what I see.
Right. Yeah. And so when you say stringing things together, what exactly do you mean by that? I think I have an idea of what you mean, but I just want to hear it from you.
Yeah, so the idea behind the service layer, again, the one that I'm familiar with, the good old service repository pattern, is that you have all of these super like tiny dependency heavy reads and writes to your database or to your external services that you're talking to, right? All your dependency stuff lives there. The services is just an abstracted layer on top of that, whose job is to say, okay, make this individual call here and then do this with the result of that. And it's a lot of if else's, it's a lot of cases, a lot of switches, things like that.
Right. So, or maybe you mentioned the Saga pattern, stringing things together. Something that I've seen a lot, and I don't know if like this is the norm. I really hope it's not, but it's choreography, where you basically have, let's say you have service A and then service B.
You beat me to it.
And then service C, and it's basically like when A is done,
then talk to B. Then talk to C.
Yeah. And so the problem with this, I mean, it should be fairly obvious that if something bad happens, like I'll just use a pen over here, and let's say something fails, you are SOL,
completely. And so we end up what I would consider over engineering, right? You end up so you take I'm so glad you said this. So I was thinking in terms of an individual service, but when you're taking multiple service and choreographing, stringing them together, you have to be super defensive by the get-go. So if something fails between B and C, for instance, the accepted paradigm is to, hey man, well, listen, throw whatever B was supposed to do on a queue, and let's hope C comes back at some point, or we can, restore C to be able to process that event at a later time. or
Oh, so
have
this
some
would
really
like
good logging in place.
it would like loop back and then just wait for. So basically,
Yeah, just wait for C to be active.
B has to deal with C's crap, basically.
Pretty much, yeah, yeah. C's always been a problem child. We try not to talk about it at holidays, but eventually it's going to come up. But once
Yeah.
C decides to get its life together, it's going to look at something like that queue, right? Or whatever bus responsible for holding on to messages is, and it's going to start processing there, and then the entire system can resume. But it is by definition a traffic flow, sort of like a traffic blockage, sort of like an artery just completely blocking. That's a terrible visual I just gave the audience
Yeah.
there, but we won't.
Yeah.
We won't dig too deep into it.
We like having interesting analogies here at Stately, but
That's what we do.
yeah. So I mean, I would say that at least in my experience too, and I come from more of a PHP background. That yeah, it
Oh,
is
I'm
basically
sorry.
this choreography pattern where it's like do this and then directly call this service, and nothing was really distributed. You had everything in the same process, but the
Yeah.
idea, and I don't know if this is a microservice thing or otherwise, is that instead of that, you basically model what should happen in some orchestrator. And so I could just put that
Hmm.
here just to show. And, we're basically modeling that A should do something, and then B should do something else, and then C should do
Hmm.
something. And so that way, this orchestrator is responsible for calling A, and then A will get back and say, like, hey, I'm done. And then it will call B, and then, B will come back and say, yep, I'm done. And, same thing for C. And
Yes.
I honestly think this has a lot of benefits, even though you incur the cost of a little bit more complexity. And these arrows, like, this is just like you could think of, async await
Yeah,
or
just
whatever.
messages. Yeah,
It's not that
async
scary.
messages.
Yeah.
No, it's not. I think there's a lot of value to that. And that is something that you do see in .NET land, particularly with things like I love durable functions, Azure's durable functions. They are pretty comparable with like AWS. Goodness, what are they called? The Lambdas, but they're persistent, right?
Mhm.
So you'll see this pattern a lot where one durable function is responsible for being the orchestrator, and it can spin up individual actors, right? Or Azure calls them durable functions, but in essence, they are actors that all execute their thing and report their status back to the orchestrator. The problem is that the code that I've typically both written and have seen written is really hard to follow, right? It's really hard to figure out, okay, where does orchestrator logic end and actor logic begin? Because even though I may know that I'm spinning up these individual processes, it's all sort of defined in the same place. And I kind of have to fish around to see what's what. So that is, in my opinion, one of the fallbacks of that particular pattern, but it works excellently at scale.
Mhm.
And the beauty of thinking that everything is an actor is if C, again, the problem child, C, my goodness, if C just decides not to get itself together for whatever reason, the silicon doesn't matter, right? I can just kill C and spawn another C, right? Yeah, that one dies, that one wakes up again. It's that borrowed concept from, I believe it was Rust. Everything is an actor, right? And actors are sort of they're recyclable, they are exploitable, and they can be thrown back and replaced at any time.
Yeah, exactly. And that's one of the good things about having this orchestrator, but of course, it could get complex.
Mhm.
But honestly, I think the pros just definitely outweigh the cons. And another
100%.
thing
Yeah.
too is that you don't necessarily like I know that a few years ago people gone crazy over microservices, or like everything should be in a microservice.
And then
This
we've gone back.
Yeah,
We're back into macro services. Yeah.
exactly. This whole like A, B, and C thing, I honestly think that the idea of having this declarative logic over here, like, hey, we should do A, and then when A's done, do B, and then when B's
Mhm.
done, do C, and then we could get more complex over here. This doesn't mean that each of these have to live in their own microservice. This just means that, these could be a part of the same process for all we care.
Yes.
So, and that's the whole location independence thing, or whatever it's called. Basically, these could live anywhere. It doesn't matter. You're just
Mhm.
sending events. And so
Yeah.
that's where we sort of get into state machines, because with state machines, you have this orchestrator where it's not that it doesn't care how the things get done, but it's just orchestrating. It's telling, like, hey, A should be happening
Do the
right now.
thing.
Yeah, and then B, and then C.
Mhm.
So
Yeah. To clarify a bit, just for both my benefit and I think for the audience of the potential viewer, hello, your benefit, is that this sort of it does differ from microservices in that the biggest Achilles heel of microservices is that you have to often deal with, well, how am I going to be able to deploy these individual bits of code to these bespoke services? Am I going to use a giant mono repo and just deal with a folder structure that's okay with deploying from individual folders? Or am I going to use, a multi-repo approach where I now have to version lock and manage and all of that good stuff, like manage contracts between these individual services? The one benefit that the orchestrator approach like this, the actor-based approach, is that all my logic is effectively defined in the orchestrator. The orchestrator holds the blueprints for A, for B, for C, and it'll spawn up what it needs, right? You don't have to worry about rolling out a canary update just for actor B here. You would update the orchestrator, and the orchestrator is the source of truth. The reason I say that that's a potential trade-off is that, no approach is perfect. Now you have an orchestrator that's pretty code heavy. You need to find a way to orchestrate that. And I happen to think, totally unbiased, by the way, I happen to think that XState is a really good way to sort of create that separation of church and state between your orchestrator and your individual child actors, or, separate orchestrators, even, through the use of state charts. And I'm off my soapbox.
And yeah, I'm a little biased about that too. But yeah, so something else I want to talk about just on the same topic is the whole serverless aspect. And I titled this stream "Making Workflows Serverless." And that's because in a serverless world, things work sort of differently. Your functions have a maximum runtime of 15 minutes? I guess it depends on the platform.
10 in AWS land. Yeah.
Yeah, exactly. And you have to assume, you absolutely must assume, that whatever workflow you're trying to model can last for a very, very long time.
Yes.
If you're modeling, for example, an approval workflow, you might be waiting 30 days and then the approval expires, etc. You have to do some logic there. Or maybe you want to model an email workflow where that could take a while, and that could last years, hopefully, where it's like, okay, let's send a message every single month. So with the serverless approach, it's actually pretty interesting, but it does add extra layers of complexity, because with your typical serverless like Lambda or something like that, you do something, hopefully it lasts for less than 15 minutes, and then it's done. Like your Lambda could shut down, it could just be destroyed, whatever, or you could keep it awake with cold start, just like removing that cold start and just
and say
giving
goodbye
it
to your wallet.
Yeah. So one problem with orchestrators is that if you're trying to model like, hey, do this, then do that, then do something else, especially when you're using async awaits or just something like that, then let's say that A takes a really long time to do, and you're trying to model this in a serverless way. The problem is, all right, so A comes back after 30 minutes or so, and you have to continue what you're doing. But the orchestrator, since it was shut down, it has no memory of ever doing A. Yeah. So basically you have to start again, or something. Like I honestly have no idea. I think we just wire together things, like put things on message queues and just persist triggers. Things to storage. Yeah, triggers, things like that. And just hope that the orchestrator has the logic to revive it at a certain point. And these are things that we basically have to hand code or just hand off to a third-party service. And so that's where actually durable functions and technologies like temporal, etc., and this idea of durable execution comes in, because what they do basically is when an event comes back to the orchestrator, it says like, hey, I was at this date where A was already executed. So now we could just
Mhm.
start at B. And then,
Yes.
same thing over here. Like, okay, I know that A and B were already executed. So now we could just start at C. And so when these wake up, it has this idea of, I know what my state was before.
Yeah, exactly. And I want to be a super just double click on that for a minute because as developers, we should not take that for granted. Conceptually, it may seem simple, but you can think of it as sort of like an async API approach, right? Where at the end of the day, I know that the orchestrator has initiated the message that needed to be initiated. It can go to sleep if it needs to, in order to, because at the end of the day, these are real services. They are running using real processing time on someone's silicon, right? Which means that there is going to be some sort of cost associated with it. Ideally, we don't keep an orchestrator running just because it has to be alive all the time. You could do that, but ideally you don't. And think runtimes like durable functions. That just happens to be the one I'm most familiar with. I'm not particularly partial to it or against it, but that's the thing that services like durable functions give you out of the box. They have handled that logic for, okay, it's time for the orchestrator to wake back up again. So you as a developer don't have to do that. And you as a developer don't have to keep a long running service just to say, hey, did this happen yet? Are we good? Should we go? No. Okay. And the other side of that coin is, well, when it wakes back up again, how does it know what it's been doing? And that's where that that backing state store comes into the equation. Like I know that, this is the part that I'm really opinionated about. So I know that like Azure offers its own way of doing it. Everything lives in an Azure table, but the problem there is that every row in an Azure table is effectively its own actor, and there's a storage limit associated with that. I think about maybe 10 megabytes or something. So if you needed something more, you're going to have to swap out your own database layer or your own method of storing state that is more flexible and accommodates your needs. But in theory, you could do it with a SQL approach or no SQL approach, whichever you like.
Mm-hmm. Yeah. And so I think, like there's been a pattern here. I think you know what I'm going to say next. And there are downsides to this. There's complexity involved. And so that's because durable functions and things like temporal, and there's new players like ingest and trigger and all of these like really, really cool technologies. The way that they basically work in durable functions works too. And a lot of these I guess services are spawning up. They work by basically trying to capture the execution state of your stack. So what that means is, like, as your program is running, it's basically trying to, I guess, take a snapshot or know like where it is in the process, so that it could sort of save the state. And so it's doing this for one reason. And the reason is that we can't predict like where things are going to be. Like there's no way of saying like, hey, I'm going to just shut down here and let me just put a little checkpoint so that when you reload the function, you could just start at that checkpoint again. Because you have things like async awaits, you have concurrency, things like that.
Fire and forget effects.
Yeah.
So many things that you don't want to re-execute, but you still need to replay, right?
Exactly.
You still need
to
catch up.
The replaying is where the complexity comes in, because now you have to basically follow the rules of these, I guess, these services. And, just make sure that every call you do is deterministic. And if a call made a side effect, you want to make sure that that side effect is not replayed. Because again, like Gavin said, you're replaying everything from the start. So there's just some complexity there. But
unless
honestly,
that effect is payroll and we just have to execute another payment to Gavin, I'm fine for that. We can do that.
Yeah, don't want bugs like that. But yeah, so
Darn.
that's I mean, it's honestly a really good solution. And so you're basically you're abstracting away the whole fact that the lambdas are going to like shut down and then come back, and they only last for 15 minutes, but you need to model things that might last for hours or days. Like that's all abstracted away. And so that's something that's pretty nice about that approach. Again, I'm biased, but there's another approach that I think is really promising too. And it's something that people have been using for years. It's not anything new, but it's the idea of using a state machine as a workflow. So state machines, The thing I like about state machines versus like the whole implicit, you have to, keep durable states and basically replay the execution stack, is that you already have these built-in discrete checkpoints for when your workflow should stop, or like when the Lambda or whatever you're running it on should stop, take a snapshot of the state, and then restore it to that state. I have this example over here, and I'm just going to open the visual editor. This is a donut example. And so, whoa, zoomed in pretty far here.
Now, what about donuts are stateful?
Well, this is making a donut. So,
okay.
I'm not saying that making a donut takes longer than 15 minutes. Maybe it does. I have no idea. But here's a quick example. So we have ingredients. And so, once you gather your ingredients, now you have a few things that you need to do. You need to make the dough, mix the dry dough, mix the wet dough. And when all of those are mixed, then you need to fry it and then flip it and then dry it, then glaze it, put whatever you want on there. And then, of course, finally you serve it. But this workflow doesn't end because who could stop at one donut? So,
amen.
Yes. You have
Yes.
to go get another donut, and then the workflow happens again. And you can imagine, like, this is a pretty simple workflow, but the workflows could get more complex. And again, this could last for longer than 15 minutes, to do an entire cycle. Maybe you're busy, maybe the donut shop has to close for a day. Very contrived example, but just to give you an idea. Now, if you go on the XState repo, at least the version 5 branch, which is at next. So I think it's /tree/next, or I have no idea. But there's
let's see.
Yeah, there's a bunch of workflow examples. And so these workflow examples actually assume that you're just running these workflows. Like you could see over here, we're interpreting an actor, we're subscribing to it, and then we're starting it. And because we have some async, like we're invoking a promise over here, and this is that send email promise, the node process is going to be kept alive until that promise is done. So these are like just very short workflows. They're going to take less than 15 minutes. And they sort of assume a serverful environment. But we've had questions about like, how would you model this in a serverless sort of way? So
to pause your flow just a bit, David, I did confirm that the XState v5 branch is at github.com/stately.ai/xstate/tree/next. So go ahead and grab that link, and if you want to pop that up here as an overlay. I don't have the ability to do that on my end, but I feel like it's a good thing. There we go. It's a good thing to share. So there's that. And also, like, as sort of a parlay back into what you were talking about, I think the biggest thing is to define. We did a little bit at the very beginning of this call, but what is the difference between a serverful and a serverless environment? We did talk about runtime restrictions, like how long do you have before you can execute your processes? But is there anything else that comes to your mind that creates that delta between the two?
To me, I'm not sure. Because really this is about smoothing the gaps between serverful and serverless, where ideally you would want your workflow to run the same way, whether it's serverful or serverless. So
yeah.
Anything in your mind, or?
Yeah. I'm sorry to throw you a bone and completely miss, but the biggest thing for me is sort of a philosophical approach, which is when we think serverless, we think of individual functions. We think of not just code that happens to run in a really short amount of time, but also code that is scoped really tightly. So we tend not to look at it from a larger sort of business layer all on one serverless function sort of perspective. We look at several serverless functions all making up the business layer. Whereas a serverful environment, we may think of it, it can go either way, right? You can have a traditional microservices approach, or you can have a even more traditional macro service approach where one web app rules them all, that sort of thing. So I just wanted to get out and give the viewers what our perspective is on serverful versus serverless, and why XState v5 may be a bit more biased towards one or the other, which I don't think it is, but I'll let you hop in on that.
Right. Sorry, I was making a state machine.
That's what we always hear from him, by the way. We're like, David, we need help. And he's like, I'm sorry, I was making a state machine.
Sorry. But yeah, so sorry, my brain was in one spot.
Oh, it's okay. It's okay.
Anyway, yeah, so this is sort of an example of what I'm thinking for a serverless workflow. And yeah, so with the serverless workflow, things work a little bit differently, where when you have an event, I should have named this something better, like any events, then that event is going to, assumedly wake up the Lambda. And so we're going to be in this reading state because we need to fetch the state from somewhere. And actually, let me go back in design mode because I forgot something.
Yeah.
Hold on. I'm not used to this mouse, but even though I've had it for a few years, I'm still not used to that.
That's okay.
All right. So we're going to be reading the states. And then once that's done, we're processing the event, and then that's processed. And then we could easily add something to handle errors and things like that. But then we might have effects that are executed. In fact, we could say that if there are effects, so effects, and we need to execute the effects. Otherwise, we need to just go back to persisting the states. So this will go over here. So executed, and then could drag this here, and then just done.
Oh, you're like lightning. Look at you. So,
yeah.
David, you're eventually going to go back to the very first, which is reading state. In a lot of serverless contexts, you would see this written as, you might hear the word hydrating a lot. Hydrating and dehydrating is a really common concept in durable serverless workflows. So that is effectively the Lambda or whatever insert serverless, platform here. That is that function waking up, looking at the database that it's assigned to and seeing, okay, well, what happened before I was born or before I woke up? And if the answer is nothing, then it's great. I know I need to start at my initial state. And if the answer is, oh yeah, you did this earlier on, this is where you are in the process. It's been more than 10 minutes, so I went back to sleep. It can now say, oh, okay, I was sleeping then, but I've been woken up again for whatever reason. That could be time. It could be an HTTP request. It could be a database operation, whatever trigger you want it to be.
Yeah, exactly. And so the reason that works in this model is because, I wish I had colors in here, but I have to sign in and actually
colors are helpful.
They are helpful, but I am in the simple browser extension of VS Code, and it doesn't let me log in via GitHub inside of here for some reason. It's been a little bit weird about that, but it's all good. So I'm going to add
PR to me.
Yeah. But yeah, so what Gavin said is correct. And you might think like, can't that take longer than 15 minutes? But the answer is no. Or actually the answer is hopefully no. We could never assume, but let's just, if it takes longer than even a minute, and I'll show you why in a minute, then something went wrong. Like something is terribly wrong with your actor. But okay, if this is done and we have events in the queue, we actually just have to keep processing those events. And actually, I think this is a pretty nice model of how everything works. So I'm just going to call this event. And all right, so I think we're good to go. This is the basic model of how a serverless workflow might work with Stately. So let's say, right now our worker is idle. And again, this is a serverless worker.
A serverless workflow. Yeah, you were right. A workflow. Yeah.
I want to say function and worker. So
yeah, that's words. Fine. Yeah. We may use Lambda function worker interchangeably, but we're all talking about the compute unit that is a component in a serverless workflow.
Right. So let's say that we get an event. So first we're going to hydrate the states, and this is reading the state from the database. And then when that's done, we have to process the events. Now, keep in mind that state machines just by their mathematical nature, transitions are always 0 time, or theoretically 0 time. And so what that means is that there should be, it's basically a really quick, hopefully synchronous operation where it's basically answering the question, you're in this state, this event happened, what's the next state that we're at? So, and that should take, close to 0 time. The only reason it could take sorry, go ahead.
Oh, go ahead. Oh, okay. Yeah, this was so sorry. This was a bit heretical to me at first when I learned about XState. Was like, well, how can transitions be 0 time if in theory I could live in a state for forever? And that is because the act of transitioning is 0 time. The actual transition has to be driven by some sort of event or some sort of change outside of the state machine that it has to respond to. So if anyone else is having that sort of disconnect, then that's my understanding of it now, which is to say processing event, the act of processing that event could take forever, and we may still be in that state, but we'll know that we're out of it when we receive the next event to move on. And that transition is 0 time.
Yeah.
Is that fair, David?
Yeah, that's fair. I just thought of a really ridiculous analogy. So, for example, Gavin, what would you do if you won the lottery? It's the first thing you would do.
Well, I'd call my mom.
Okay.
And then I would gloriously resign from my job, and then no one would hear from me again. I'd move out to an island in the Bahamas.
Okay. Yeah. So call your mom, quit your job, and then move to an island in the Bahamas. And you said that within, like a few seconds. And
yes,
it seems
100%.
like you already had that answer in the back of your head. So yeah, the analogy I wanted to make is that processing the event is the act of basically saying, like, I have an answer to this question. Like,
yes.
Actually winning the lottery is going to take a lot of time if it ever happens. And, calling your mom might take a few seconds or minutes. Moving to the Bahamas might take even longer. Quitting your job even longer, because we have people that will keep you here forever.
Yes, 100%. Yeah, I'm not going anywhere.
Yeah.
You guys can't see, but there's an ankle cuff under the desk.
Right. And so that's what we mean by 0 time. You're in state A, event happens, the state machine is just telling you state B. So what does take a long time? Let's say that there's effects. Does executing effects take a long time? Actually, no. Because these are basically fire and forget. And so I think that's the other mental model is that when you're executing effects, whether it's an action or whether it's you're invoking an actor, you're just starting it. And especially in a serverful or serverless world, it's technically still fire and forget. Even when you have an actor that's invoked, you're basically invoking it and saying, like, hey, call me back when you're done.
Yes.
So that's a difference between invoking and just doing a fire and forget, is you actually care about what that actor is doing. So
yes, the most
that's also 0 time.
100%. The most you would get from a serverless sort of function is the fact that the event was received. That is the only response you can really be guaranteed on, especially if it's a long running task, right? So sort of like sending email is a really good one, because you can't, if you're sending email to 100 people, there's no way you can get 100 responses back after the email is sent that says it's been sent. But the service responsible for actually executing the send action can tell you, yeah, I got it, and I'm going to do it, but you won't know the results of it at the end of the day.
Right. Yeah, exactly. All right. So let's say that they're all executed. And I guess the only way it could take a long time is if you have thousands and thousands of actions. But even then, we're talking milliseconds or seconds. We're not talking hours or something like that.
Right.
Now, this could also take some time. This is non-0 time because we have to save the state to the database. And especially if we want this to be an atomic operation. I don't know how atomic we could get, at least with XStates, the whole state transition is atomic in that the state will only transition if you don't have any errors when executing the actions. So if you have an error, it's sorry, we're crashing and burning. We're not transitioning the state. But persisting the state, that might be something that could fail. It could take a long time. Hopefully not. Hopefully you have a decent database. But all that to say is that it's basically only these two, hydrating state and persisting state. And these are what take a long time. So this takes a while. Oh, and this is our annotations thing. So you could have annotations.
So cool.
Yeah, I think there was one that snuck out. Oh wait, just kidding. Just add it here. All right, so yeah, this also takes a while. And a while is, and it's just error time. So the reason that this works, and the reason it works in the serverless context, is because the only two things that will take a while are hydrating and persisting state, and that's really up to the speed of your chosen database.
Right.
Yeah.
And now there are tricks to the trade there. Typically, if you've got a really fast SQL database and you've done your modeling in a way that your lookup times are not going to be crazy, even though this can take a while, it's very, very you're on the milliseconds level, right? Like you're not really worried too much about that. If you find yourself hydrating for 5 seconds and there is a problem.
Right.
Yeah. Now, NoSQL may be a little longer because you do have inherent overhead with indexing in NoSQL databases, but in theory, it should still be very quick.
Yeah. So let me just go back to, oh, wow, that you can't see at all. But back to the whole like durable execution model, where you basically have, I call them events, but they're not really events. They're just occurrences in time, which is technically what an event is, but it's not a discrete event. That's sort of what I mean by that.
Got you. Okay.
Yeah. So let's say you have event. You have a bunch of events. Basically, you have to replay all of these, and you have to go stack by stack, or stack call by stack. I have no idea. Basically, you're going through the execution stack, and you're
row by row.
all of those. Yeah, you're replaying all of those in order to get to what the state you were last on. And so eventually, you will get to some place where you haven't executed yet. And so that's how you know, okay, this is where I was at, and I have storage saying I've already executed this part of the function. And so a common issue with that in event sourcing is that these could get really, really, really long. Imagine a function where you're just doing a lot of stuff. You might have easily thousands,
Easily thousands, which does take time. And David, what if, pick the 5th event there, what if that one didn't make it to the database for whatever reason?
Oh yeah, so that's tough. I mean, we do assume like at least once execution. So hopefully it does. And I guess in this whole thing we're assuming it does. But anyway, so that's why let's assume that we just have like thousands of these events. That's why we would have a snapshot.
There we go.
This is a strategy that some event sourcing technologies use, where it would say like, hey, we have some notion of a snapshot, and all you have to really do is replay the events from that snapshot, and then you sort of have this model. You have sort of a hybrid between the event sourcing and the, I guess we'll call it
checkpointing.
Yeah, sort of a checkpointing model. Anyway, all that to say is that I have a small example over here just demonstrating this as a proof of concept. And our storage is going to be a JSON file, which is a little bit silly. Yeah. In fact, I don't have the JSON file here. I think it will actually write it. Oh, so it does check if there's no persistent state found. And so what's going to happen is that we're going to take in an event, and that's, just calling this function. And how do I send this event? Oh, yeah. So I literally just, I send it the string. So, yeah. And actually, let me just pull up this handy diagram so I could see which events I have to send it. But yeah, so what's going to happen is we're going to get the event, and it's going to send it to the actor, which is running. And then we're going to just model what happens if this actor stops because it's past 15 minutes or just already transitioned, and we could say, hey, this actor is not processing any more events, and it's going to save it to that file. And then when we start the actor again, we are going to just restore the state of it. And so we already have that checkpoint because we're just reading the file. This is David's very, very cheap database. It's called fs.read file. it works. So
it works. It works.
Yeah. All right. So let's see how this goes. I'm just going to do npm start or pnpm start. And actually, this thing's pretty cool because it does tell me what are the next events that I could do. And actually, let me just pump up the size over here. I'll do all the way 32. Okay. So it says enter the next event to send. And it's literally just next. And so right now we're at directions, make dough. And, things are still going quickly, so I could send another event. So I already made the dough. And now we're in the state. And this is the state being persisted. So what I'm going to do is I'm going to shut down this actor completely.
And boy, did you. You shut it down so many times.
I made sure it was dead. Yeah.
Kill it with fire.
We are going to start it again. Let's say that, we send in events. That event wakes up the actor. And so we're going to start it. And you could see we are at exactly the state that we left off at. So we could just continue as normal. Yeah. So we can mix dry. We could mix wet. And now we're in the frying state. Then we could stop it and then start again. And so, the way that works, again, we have this neat little JSON file, and it's storing a few things. Honestly, and this is going to change in version 5, but really the only things you need to store are the value and the context and the children if you're invoking anything, but that's pretty much it. Like all of these other things don't really matter. History value if you're using history states, but that's pretty much it.
Now, what about the event, David? Why wouldn't I feel the need to store the last event that came through?
So, you could absolutely do that. In version 4, we honestly did it for convenience. We stored the actions in the event. And it was very useful for inspection, but pretty much nothing else. And so that's why, and you helped me work on this. In version 5, we have an upcoming inspection API where you're going to get separate events. And it's because these events might not be one-to-one with the state. So instead of being tied directly to the state, you might be listening to the system sending you inspection events saying, hey, this actor transitioned, or this actor tried to send in events to another actor, or this actor was created from this actor, or this action was executed, or, various number of other potential events.
And those are really important for things like observability, for things like auditing, for understanding what's actually happening in your system so that you're not talking to just the black box. And the beauty about that, with XState v5 and the way that we're implementing it is we definitely plan to roll in a first-class citizen for these inspection events and things in our studio that you can use. But a client, the studio is effectively going to be a client for visibility, right? And a client is a client is a client. And, the spec for that will be available. It's open source. So if you wanted to build your own, you can totally build your own. Yeah.
And I actually rediscovered there's a really cool project called XState Ninja. In fact, let me just pull it up on the screen.
I like ninjas and I like XState.
Cool. I do want to share this. Okay. So XState Ninja is very, very cool tool by our laughers. Love the logo. I love the dev tools over here.
Awesome.
Yeah, it adds dev tools for XState. I think this is just for basically your machines running in the browser. One thing that we're most interested in is machines that run anywhere, whether it's on the server, whether it's on embedded devices, or React's native mobile applications, and in the future, other languages. And that's why we're working on this protocol, the actor events protocol that I talked about. Because then it doesn't matter if you use XState. You could really just send those events from anywhere. So, you could see. Oh, this is cool. Like, yeah. Absolutely. And so you could see that, just different actors. So this is like a vehicle, the car ignition. You see the context action services. This is just beautiful, honestly. Long list of to-dos. But yeah,
I love
definitely
that.
check it out. It's called XState Ninja. And it's just you npm install XState-Ninja. Super, super cool stuff.
Well, this person is after my own heart right now. I'm happy to have learned this existed. I know we did. We talked about this actually in Discord not too long ago. I remember now. It's very cool.
Mm-hmm.
But yeah, effectively that. You can have your own inspector if ours doesn't quite do what you need it to do. Or you can always hit us up and ask us if there are any features that you'd like to see added to the inspector once it becomes a thing existing in the studio. And if there's enough fanfare around it, we'll be happy to add it.
Mm-hmm. Yeah. So I guess for closing words, since it's already past 5 over here, is that like the idea of running a state or running a workflow as a state machine really gives you a lot of flexibility. And I think like I personally am allergic to the fact that if you want to run a workflow that has all of these properties like durable execution, fault tolerance, reliability, etc., you need this very specific and special and hard to set up infrastructure in order to do that. And I think that if you go with a state machine approach, like we showed you, you really don't. Like you see that I have a state machine running, it's accepting events, and you could easily throw that up in a Lambda, in an edge function on Vercel or Netlify or numerous other services, whatever you want. And basically, you store the state, do exactly as I showed in the state machine. You store the state, and then you hydrate that state once an event comes in. And then you process what should happen next, execute the effects, and then, Devin said, or you need to learn a new language like ASL, Amazon State Language, which is also super annoying. And in fact, I'm going to throw this up on the screen because it's it's really, really interesting. So I was here. States language. Okay.
+1 to that, Devin. And I also want to throw out that even then, right, you're still chained to Amazon's implementation of that, right? They're stateful lambdas, because this doesn't work in other cloud vendors, right? So, and I'm pretty sure that their runtime isn't something that you can just, lift and shift over to somewhere else. What I do like about, XState is that, what is our spec, David? Other than the state chart spec that has been around since before you and I. That's pretty ubiquitous in the field right now, and not just the field of software engineering, right? Like there are plenty of other conceptual approaches to state charts that are used well outside of that. So I really prefer something that feels like, oh, I can learn this and be effective in any role I take, whether I'm working 9 to 5 at Stately, or I'm working at, I don't know, whatever's left of Yahoo's software dev division. So I'm kidding, of course.
I will say that States language does have a few cool things. It has, I think it's either similar to JQ or it is JQ, where you could just say, hey, the result path is here and it should be passed to this date and things like that, which is interesting. And also it has the idea of timeouts, heartbeats, retries, things like that. And I think that after Gavin and I did a stream a while back on it, I'm almost convinced that we should have retries built into XState. We'll see.
At the very least, we're thinking about hooks to popular retry libraries that are out there, sort of like in the way that popular logging libraries can look at different destinations as logging sinks. We were, entertaining the idea of having something like that, but for retries, right? So in C# land, like Poly is the big one. And JavaScript land, I've already forgotten. What is it, David? What's the one that everyone uses?
Cockatiel.
Cockatiel. Oh, that's so cool. I was about to say parrot, and I knew I was wrong.
No, it's modeled off Poly. Yeah.
I knew it was a bird. So maybe hooks in for that. And the other big thing is the same way in David's example, where he was writing to a JSON file, you could have an environment variable sitting in whatever compute, or infrastructure you're living in, right? Just have an environment variable with a database connection string, and you can write that anywhere. right? I think our big goal here is getting across the notion that you don't have to live by the idioms of the runtime that you're working under. This could run in a serverless context, this workflow that David created, or you could just have a plain old web app living somewhere with your own timeouts implemented, right? You could just say, hey, if this thing's idle, just let it go to sleep and then wake it up when you need to.
Yeah.
So I like that. I like the portability a lot.
And yeah, and that's honestly one of the most important things to me. I think that Amazon Step Functions is super cool. And in fact, they have this visual designer similar to ours, but I mean, we do state charts, so we could do a lot more things. Like you could have nested states, and you could have actions and invocations and things like that. Can't even think straight right now, but there's a lot that you could do. But this, you see Amazon is literally written all over it. You can only run this on AWS. You can't take this, you can't run it locally like you can with XState. And so, yeah, it's not portable at all. And so what I think that was one of my original visions with Stately is I really want something where you could basically do this and then run it absolutely anywhere you want to. And the whole like, we need something that's fault tolerant and reliable and monitoring, etc. Like those are things that you could easily add on yourself, or in the future we could provide those services for you too. And but still, the main idea is that you're a developer. The choice should be yours as a developer to choose where you want to host these and deploy them.
100%. And not to have the last word, David, but there is one key distinction I want to pull in, a sort of the value of XState on the back end as a workflows engine, and compared to XState on the front end as sort of a UI management library. The cool thing that you have on the back end, especially if you're working in like I'm going to use it as an example. Let's say you're working in a Node.js context, right? And you have to have several actors all doing their own things on their own threads, right? Well, now you've got processes. Now you've got Node.js processes. You can just spin those suckers out and have them run, as distributed as you need to. It is a thing that you can do that you can't quite do on the single threaded nature on the front end. So I just wanted to throw out there that, there's a little performance benefit there for back-end workflows.
Yeah,
very
for sure.
cheekily.
And honestly, that's why I like actors so much, is that actors really abstract the idea of it doesn't matter whether you're on a single thread or multiple threads. It's basically you treat them all the same, where you have a different process, and they could be on what's called a virtual thread, which basically it looks and feels like a separate thread, but it's still the main thread technically. But it shouldn't matter whether it's on a separate thread or not. And that's one of the hugest benefits of the actor model. But we could talk about that all. Say that for another
show. We'll have that. We'll do that another time. Yes, I just needed to get it out, and I'm glad I did.
For sure. All right. Well, I think that we'll call it there. Thank you all 4 or 5 of you, for joining us and watching. I know this was a late impromptu stream, but let us know if you want us to have more of these, and if you want us to talk about anything else having to do with app logic, serverless workflows, serverful workflows, and anything else you could use state machines in the actor model for, which tends to be most of software. So there's a lot of topics we could choose from.
Yeah. Turns out. Yeah. Please do keep us posted. And if you're not already, check us out on our XState Discord. Come say hi to us. And if you run into any questions, concerns, we are very, very active on the platform.
Yep.
Yeah, discord.gg/XState. Sorry.
Yeah. Since you're watching, just keep in mind, this is basically free support. I'm on there all the time. So I'm like, okay, I will help you fix your problems. So yeah.
Literally. Yes.
All right. Well, thanks everyone. Talk to you later.
Bye, y'all.